So this came my way a day or two ago. It's a classic TV game. It's a Velleman kit, NTSC. I thought we'd go ahead and assemble it together. There is an IC in the kit. I'm assuming it's probably a General Instruments Pong chip, although I have no proof of that. So let's see what we've got. Not a whole lot of instructions here. Where's English? Battery operated, video and audio output, adjustable brightness, auto power off, one player mode, 4 difficulty levels, select 2-player mode, press both buttons to smash or to start serve. Only the server can score points, so that definitely sounds like some kind of Pong. Here be our instructions. Well, look at that. That's just a not even tin plated. Single-sided, as inexpensive as they could make it. Not tin plated. Let's see what this is. The symbol of this unit or the package indicates that disposal of this unit after its life cycle could harm the environment. Okay, and that's because it has lead. Battery holder. Oh, it uses a PIC. PIC 16C505. Well, that's kind of a disappointment that it's a PIC, not like a custom GI chip. But it is what it is. Looks like 1.2K. And are those 1 ohm? Huh. 2K2s, we'll have to keep looking. Bag of stuff. 4 feet. $1K. There's a bunch of 1.2K, which is these one. That's brown. Pretty sure that's brown red, which would be 1.2K. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that's that group there. Want to see if there's some loose resistors in here. What value those are? The are there loose resistors in here? There are. Resistor. Try to keep the hardware from all vanishing. Well, 5 switches. Oh, I'll bet 2 of them are. Does it actually use switches to move the paddle back and forth? Up, down, up, down. It sure as heck does. Wow. Less and less impressive by the second to me here. I actually thought it was going to be a Pong game. You know, with the joystick. You know, I don't want to say analog joystick, but literally analog joystick. But it's not. There's another one of those spacers. Nut. For those kind of bolts. A couple of those countersunk screws that I suspect are for the battery holder. We've got diodes. Lots of diodes. Which is interesting. There's another resistor. This is what I get for trimming my fingernails a few minutes ago. Can't pick anything up now off the bench. Electrolytics, another spacer, some disc caps, a socket for the pick, and a potentiometer, I assume, for brightness. So 2K2, there should be 2 of them, which look like these 2 resistors right here. I'm going to go ahead and verify them. I've got a decent tip on there for soldering. Eyes are not what they used to be. Yep. And this one is, I know you can't see this, is 2.18. Okay, so those are the 2.2K, so that's R1 and R2. There's R1 right there. Find R2. Gee, I wonder if this would be a candidate for my assembly jig. It actually would be. I don't know why I'm not using it. Here's R2. So let's bring the assembly jig into the shot here and give it a try. Since I haven't done a whole lot with it yet. Definitely now too loose. Got the board in upside down, but that's fine. We just flip it over. We spring or use the to hold the resistor in place. As it's bare copper, I'm actually going to add some flux. Don't need to add a lot. And we will solder and see what we get. Resistor over here. Just a tiny little drop is all I'm putting on. It doesn't need a lot. There may actually be enough flux in the solder, but it's not going to hurt to add a little. What I do need to do, however, is find the flush cutters. A pair that actually work. We move on to R3, 4, 5, 6, 7, 8, and 9, which are 1K2. I'm pretty sure that's what these are. Let me measure one of them. 1.198K, so that's exactly what these are. R3. R3, where are you? Must be 7. What the heck? 12, R3. It's R4 in the same general area. It is. Yeah, I'm pretty disappointed this is using a pick. I'm not using, you know, a classic GI chip. You know, GI made Pong chips. I've got a video, I think, up here about a Pong game I made. I'd have to look for it. Around one of the chips and just using the default schematic from their data sheet. Which works, although modern televisions have a heck of a time with it. They don't want to sync to it, and that's because the video timings on it are pretty lousy. But older televisions sync right up, just no problem. So that's R3, R4, R5, R6. We'll keep looking. R5, R6, I see them there. R5. R6. Okay, that's R5 down here and R6 up above. You know, this little rig works pretty well for what it is. It's holding those sufficiently in place. Pads are nice and large, easy to solder. This would be a good kit to learn on, potentially. I don't know how many of the Velleman kits are like this with large pads. Very clear component layouts. Or 7 or 8. Did I lose a resistor? Did I knock one off? R7, R8. It's interesting, there's a pad there that wasn't drilled. There's actually a bunch of them now that I look. I wonder what's up with that. Well, there's no silkscreen on the board, so I guess those ultimately weren't used. So that got me R6, R7. Or they got me R7. Actually, R8 is up here. Got to pay more attention to the little diagram over there. Oops, that was interesting. Oh, the board slipped. Why did that happen? I must not have things as tight as I thought I did. Come on. And I am going to be short R9, a 1.2k ohm resistor. is R9? R9. I am short a resistor. I swear I counted those out. And I had the right amount. Not that oh, it's on the floor here. So I did manage to knock it off the desk. Or the workbench. Yep, that's the right one. That goes into R9. You can see I'm getting lots of flux residue on the back of the board. At least you can probably see that. Where it's, so I'm adding very little, and yet even that little tiny bit I add flows way out and spreads around the board, but I am getting what look to be respectable solder joints. R10 470. Should be this guy, looking at the color codes, but I will verify. 464, close enough. 470 goes to R10. Well, I can say generally that for this kit, this is working pretty well. I'm not having to bend leads at funny angles to hold them in or add tape or any of the stuff you've probably seen me do in other videos. So that's kind of nice. R10, and then we've got 100Ks, brown, black, yellow, 100Ks, or 11, 12, 13, 14, 15. So there's 12, 13, or 11. Should be 14 and 15. I'm going to do these slightly out of order because I've only got the 1Ks left. So I'm not going to get a resistor in the wrong position. And I can use the pad to hold all three of those in place. A little bit of flux. Got a little bit too much flux there, but such is life. I'm actually going to trim these leads out of the way to make it a little bit easier to work in there. Looks like all of those are tied together. And two more resistors over here, 12 and 13. Lots of labeled ZD4, Zener diode. Is there really a bunch of Zeners on this thing? That would be strange and unexpected. There's a regular diode up here, but there's all these ZDs. I just find the thought of this thing having a bunch of Zener diodes on it odd. Well, this certainly reminds me of building kits as a kid, although the board is solder masked and silkscreen, which is nice. It's not just a bare board. So we move on to a diode. And Really? There are 5 Zener diodes? Zener diodes, ZD1, 2, 3, 4. Yet there's 5 diodes laying there. Did they package an extra one? And then there's, oh, wonderful. There's a 4148 in there and a bunch of, so one of those is different from the other 4. So let's see, this is, diode 1 is the 4148, and this is the 4007. So it goes to D2. There's D1, ZD, 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 ZD. Where's D2? D2. Flux definitely is helping here. I'm not struggling to get the solder to flow onto that bare copper. It just flows right on as it should, which is really excellent. So let me see if I can figure out which diode is which. Yes, I am using a headlamp. Come on. Cannot read that. It is marked so poorly. C. Okay, that's got a 5V on it, so it's a 5-volt Zener. That's also got a 5V on it, 5-volt Zener. 5V, 5-volt Zener. There is the 4148, and that would make this a 5-volt Zener, and it is. Okay. That works. So the 4148 goes at D1. And of course there's a wide band in the silkscreen and the black band on the Zener that you align. Zeners are a polarized device, or diodes are. Both the Zeners and these regular diodes are polarized. You got to get them in the right direction. The resistors are not. They can go in either orientation. I've got 2 Zeners down there. They're all sitting up here. And in my case, the white marking on the PCB and the black marking stripe on the Zener are going to the right side. Tried to put that one in, excuse me, backwards. Oh, that was way too much flux. I got these little tubes, or these little bottles of flux. I actually found them on Amazon. Although I think it was actually a link to an eBay store, which was an interesting and kind of odd search to end up there, but that is how it ended up, and I've been very happy with it. It's a repackaged Kester flux. It took a chance because, you know, obviously somebody has remarked this themselves. Kester 951, no clean. Yeah, storesebay.com. Slave in fashion art. Makes absolutely no sense as an electronics store, but it is what it is. And it's worked well enough on enough projects now that it's good flux. I'm going to go ahead and give them the benefit of the doubt and believe it's Kester, whether it really is or not. Is kind of not super important, honestly. It works. I think the claim was you bought in bulk and repackaged, and it certainly looks that way. I mean, maybe it comes from the Kester factory like that, but I doubt it. It's not got any. It's obvious to me it's not packaged for resale. Standalone. Diode leads can all get trimmed. I am following the assembly order in the little manual here. It wants the IC socket next. Okay, I guess that works. I was looking at the cap, or two of the disc caps there, wondering if it made sense for those to be next, but I can see that all of the pins are through. A little bit of flux kind of ran along there. That's a little too much. Okay, way too much. As Louis Rossman would say, you can never have enough flux. Of course, he's not soldering old school boards like this. Still disappointed this thing's based on a PIC processor, but that's okay. Socket is in. Number 5 are the switches. I'm going to hold off on the switches. Moves on to the crystal. The switches are at the edges of the board. I need this, and this piece of wire. I'm just going to go ahead and mount the pot. I'm now kind of moving out of order. But that's okay. I'm down on these two items right here, so doing those two backwards I don't think is a big deal. It's not like they're in the way of each other and the assembly order truly matters. Resistors, or the potentiometers mounted. Crystal. I'm actually going to bend these leads with a tool because I want them away from the package slightly so that they don't short up against the package. Then I'll drop it in place, and then it uses this piece of wire as a strap to hold it in place. I'm going to, for now, solder the crystal and one of the strap wire ends. I'm not going to solder both of them yet. Now I'm going to push it down tight and kind of pull the strap tight. Oh, that was a lot of flux. I didn't look to see even what value the crystal is, though I'm not super concerned about it. There's two 18 picofarad, which is going to be those two, I'm sure. And there's 100 nanofarad, which is going to be this guy. I'll bet C1 and C2 are the 18 picofarads because they're either side of the crystal, so it's part of the oscillator circuit. These disc caps are not polarized. The crystal was not polarized. Let's hold those in place and solder away. The crystal is obviously for the PIC processor to provide its clock, and from that clock it then derives all of the timing signals to generate the VGA, not the VGA, the NTSC video stream. There is a 100 nanofarad, which is going to be this guy right here, which I'm sure is a decoupling cap for the microprocessor. Unit's battery powered. I'm not sure it needs decoupling, but I'm guessing that's what that'll be for. Take a peek here, see if I can spot the cap. Battery. Not seeing the 100 nanofarad in. There it is. Yep, decoupling cap for the processor. No surprise. We've got electrolytics, 3 of them. These devices are polarized. They have to go in the right direction. It looks like they're all 3 10 microfarads, so you can't mix them up. I'm verifying by looking at the markings. 10. Yeah, all 3 are 10s. The longer lead is the positive normally, and there's a white stripe that marks the negative lead. So always look for the white stripe, or almost always the negative lead has a stripe and is marked. Make sure you get it in the right orientation. It matters with electrolytics. And they want the capacitor kind of bent over and flush down onto the board. So we'll do that. I've got C4 up towards the top of the board. The stripe to the negative in the silkscreen, the long lead to the positive in the silkscreen. I haven't built a kit like this in a long time. And we've got one more electrolytic over here, and same exercise, negative to negative, positive to positive. They are bending it over so it lays flush to the PCB. There Here's an LED. Typically an LED will have a flat that's on the negative, so the long lead on an LED again is typically positive, and there's a flat in the molding of the package with a short lead. It's going to be the negative. And LD1 here, see if they show the orientation. Watch the polarity. They show the long lead, I believe, to the top, but the flat on the package aligns. There's a flat here in the silk screen as well, so I'm confident the LED goes in this orientation. It does sit down flush. Yep, and I can see that the short lead poking up through is going to the big copper pour on the back of the board, which is going to be ground, so that definitely is the right orientation. So that's a pretty common practice on printed circuit boards, is all of the copper they didn't etch off everywhere is usually hooked to ground. Not, can't say that 100% of the time, but that's the normal practice. You leave that copper on the board, because that way you're not, using etch it away. It's just left on the board, so it's a little cheaper to manufacture. Really getting down to the last few pieces here. We've got these nice gold-plated, which is really pretty entertaining, that these are pretty nice little connectors. The board is drilled for a number of different connectors. These just happen to be the ones that are in the kit. Oh, the flux ran through again, dripping. It's dripping all the way through. I'm getting more flux out than I thought I was. So the little center pin here is the video or audio. Center pin here is going to be the same way. It's marked. So this one's the video. This is where the actual signal is brought off the PCB. And then these 3 tabs around the outside are grounds. And I am going to get solder on those to work as a strain relief when you're plugging the connector on or off. And enough solder that I'm confident I've got a good electrical connection. This is a place where the flux definitely is going to help. And where it takes a little more heat, because you're heating up. As you can see, large pads here, and the device itself. This one didn't flow as well as I would have liked. I'm going to reflow it on the back side here. So we have video. We have 5 switches to mount. Which I really to adjust the unit. Yeah, one of the reviews I read said it's not the easiest thing to adjust, and they are absolutely correct. It is not. Let's see if that'll grab the board. And it does. The switches should just pop or should snap down in. The legs are bent such that they should hold themselves in place once they're pushed down flush. But I'll still go ahead and cover them up. They have done the layout of the printed circuit board correctly here. The upper 4 there are actually into the ground pour, but there's actually what's called a thermal relief. If you were building the kit and looked close at those pads, you would see that there's little T's in them, or little X's essentially, to hook it back out to the actual ground. It's called a thermal relief. That way you can actually solder it. Kind of disappointed that these, it isn't using like a potentiometer. It's completely digital. Oops. But it was an inexpensive kit, I'm sure. I'm not sure how it ended up surplused. But it did. Somebody bought it, never assembled it. I have no clue. One more switch. Oh, one of the leads on the switch is bent, making it a little more difficult to snap down in. I believe that concludes all of the soldering. I am going to go clean the flux off this, and then we'll pick up in a follow-up video with the mechanical assembly and the testing. So I will see you in the next video.